Assalamualaikum dan selamat sejahtera. My name is Muhammad Hakimi bin Muhammad Zamani. My metric number is AA250630. Okay, today I will present to you about transience analysis of an RL circuit, and our goal here is to determine the current expression IT for the inductor when time is T greater and equal to 0. We begin by analyzing the circuit at steady state just before the switch move at T equal to 0 minus. By calculating the parallel and series equivalent resistance, we found the total branch current I to be 3 ampere. And using the current divider rule, the initial inductor current I 0 minus is calculated to be 2 ampere. Since the current through an inductor cannot change instantaneously, our initial condition for I0 is also 2 ampere. Next, for t greater than 0, the switch change position, altering the circuit topology. We calculate the new Thevenin resistance seen by the inductor, which give us 9 ohm. And with an inductor value of L equal to 0.5 H, we find the time constant, which is equal to L divided by R Thevenin, or 1 divided by 18 seconds. This gives us a damping factor of 1 over T of 1.8. And finally, we substitute our initial current and time constant into the standard source free response formula. IT equal to I0 E to the power of negative T equal to T. This gives us our final transient current equation, IT equal to 2E to the power of minus 1.8 T ampere. For all T is greater and equal than 0. Next, let's take a look at our AC circuit simulation setup in OrCAD PSpice. Here we model a parallel series RLC configuration driven by an AC current source I1 set at an amplitude of 5 ampere. The circuit contains a 4 ohm resistor R1 and a 0.2H inductor L1 in parallel, connected in series to a 3 ohm resistor R2 and a 0.1 F capacitor C1. To capture the frequency response, we perform an AC sweep analysis. We place both magnitude and phase current probes directly on the capacitor branch, denoted here as C1, to measure how the current dynamically changes across our selected frequency spectrum. Looking closely at the simulation waveform plot under simulated circuit values, we plotted both the current magnitude and phase. The flat blue line at the top tracks the magnitude response, while the sloping red curve below represents the phase shift, dropping smoothly around minus 60 degrees down to 100 degrees as the frequency sweep from 1 Hz to 2 Hz. This visual data perfectly verifies our theoretical calculation for the AC steady state behavior. Thank you.